Welcome to Intro to Compound Interest. So we have the two formulas that we know already. Our initial of the one on the left is A, and the one on the right, the initial is P. It's also called your principal amount. Your growth factor is B on the left, and the growth factor on the right, remember the entire base, is 1 plus or minus R, depending on if you're increasing or decreasing. Your growth rate can't really be seen from the formula on the left without some additional work, but the one on the right, the growth rate is very easily identifiable as R. And remember that R is a decimal. Now we're going to have a new third formula involved, and that comes into play when we have something called compound interest. So on the left, we have an example of simple interest. If you have $100 in your bank, at the end of the year, you're going to get $10, let's say. You take that $10 and you go and spend it, go and buy yourself a meal. So the next year, you still have the same $100 in the bank, and you get the same $10 in interest, and you go and buy yourself another meal. And you're going to keep this up every single year, and every single year, you are only going to get $10 in interest because you keep investing only $100. Compound interest starts similarly. You have $100 and you invest it so you get $10 at the end of the year. But you take that $10 and you put it back in the bank. So now next year you have $110, which means your interest is going to go up. Not by much, but at least it goes up. You're going to take that $11 and you're going to put that back in the bank. And eventually, each year, what you get in your interest, you reinvest your money. And you're going to end up with more than if you just kept spending that interest each year. So compound interest is just when you take your interest, you reinvest it, and then you get more money later on. It's interest on your interest. So we have a formula to remember this. You actually have to remember this formula because it's not on your reference sheet. So breaking down this formula, we have that A is your final amount, or otherwise known as your future amount. P is your principal amount, the initial. R is a rate, again as a decimal. And N is the number of times compounded each year. So again, that's how many times are you taking your interest out and reinvesting it back in the bank. And T is the time in years. Please make sure that it's actually in years. If a problem tells you 24 months, you have to know that 24 months is 2 years, and you're using 2 in the formula. Now, your base is not 1 plus r over n because of the exponent of n. You want to get t by itself to find the true base. So if you were to put this in the calculator and evaluate the number that it would be, you would find the true growth factor and how much interest you're really getting each and every year. So the number of times you compound a year, we said was n. And again, this is just how many times are you reinvesting your interest. If you only reinvest your interest once a year, that would be annually. Semi-annually is if you reinvest your interest every 6 months or twice a year. Quarterly is 4. Monthly is 12. Weekly is 52 because there are 52 weeks in a year. And if you decide to take your interest and reinvest it every single day, that would be 365 times. So let's actually try using this in a problem. Now, in this problem, we're talking about the following functions models Teresa's current bank account. And according to the function, they want to know how often is the interest in her account compounded. Now remember that formula is A equals P times 1 plus R over N to the NT. And we're talking about how many times is it compounded, So we're specifically looking at the value of n. In this case, you could find it in two places. You're compounding 12 times a year, and there are 12 months in a year. So this is compounded monthly. Let's try example 2. We have $5,000 is invested at an interest rate of 3.5%, compounded quarterly. As soon as you see compounded quarterly, you should know compounded, use the compound interest formula that you have to remember. Because they're telling us we're compounded quarterly, this tells us n is equal to 4. The $5,000 that we first put in is going to be your initial or your principal, and the interest rate is going to be R equals, as a decimal, 0.035. No money is deposited or withdrawn from the account. They want you to use the formula to determine to the nearest cent how much is this investment going to be worth in 12 years. So that is going to be your 10. So we have our future amount will be the initial 5,000 times 1 plus the rate as a decimal over the number of times compounded to the number of times compounded times our 12 years. Now, when you go and put this in the formula, please make sure you use alpha y equals to get a fraction for the 0.035 over 4, and don't just do the division sign. This is what I mean. It should look exactly in the calculator as it does in the formula. And you'll see that we get $7,595, but they want us to round it to the nearest cent. And the nearest cent is always going to be to the nearest hundredth, 2 decimal places. That means we're going to have 92 cents. So remember, anytime you see compounding, you're going to be using the compound interest formula that you have to memorize on your own. And you're going to look to see how many times you're compounding a year to find the value of n. And that's all for this video.